Hi guys, we're going to run through some examples of simultaneous equations and then some examples of Pythagoras and Socrates afterwards. But simultaneous equations, all you need to remember is you'll get two equations that have both x's and y's in, and what we need to do is we need to make either the number of x's or the number of y's the same. It doesn't matter which one you pick, okay? I tend to try and stick with the first number. So if I'm going to make the x's the same, I'm going to make both of them say 10x. So I'm going to times the top row by 5 and the bottom row by 2. You can use a calculator if you want, but times in the top row by 5, I get 10x. 3y times 5 is 15y, and 21 times 5 is 105. What we're then going to do is we're timesing the bottom row by 2, so I get 10x plus 4y equals 50. So now that we've got the number of x's the same, because they're both positive, I'm going to subtract them. So I'm going to do top row subtract bottom row. 10x subtract 10x is 0. 15y subtract 4y is 11y. And 105 subtract 50 is 55. That way I can then divide by 11 to get that y equals 5. Once you've got one equation, you need to substitute it back in. Now you can put it into any one of your 4 equations. I'm going to use the top one just because they're the smallest numbers. So I've got 2x plus, if I know that y is equal to 5, 3y becomes 15 equals 21. And then I've got an equation I can solve to find out what x equals. So if I subtract 15 from both sides, I get 2x is equal to 6. I'm then going to divide by 2. I get x is equal to 3. So I've got my answer, x equals 3, y equals 5. If we look at a second one, now this time I've got one positive term and one negative term. What I'm going to do is I'm going to make the number of y's the same for both. Okay, so this time if I'm going to make y's the same, I'm timesing the top row by 2 and the bottom row by 3 so that I can make them both into 6. So doubling the top row, I get 8x minus 6y equals 50, and the bottom row I get 9x plus 6y equals 18. So looking at what I've got there, this time, because these two terms have different signs, if I want them to still equal 0, rather than subtracting, this time we need to add, so that minus 6 add positive 6 gives me 0. So 8 add 9 is 17x. We've just said that minus 6 add 6 gives me 0. 50 add 18 gives me 68. So what we then want to do is I want to divide by 17 to find out what x is equal to. So 17s into 68 go 4 times. So x is equal to 4. And then all we're going to do is again substitute it back into one of the equations. What I would recommend is try and avoid the equations that have minuses in. So I'm going to use this equation. Okay, so I know that x is equal to 4, so 3x becomes 12 plus 2y equals 6. So at the minute the rest of the equation stayed exactly as it was. I've now got it in a format that I can solve to find what y is. So if I subtract 12 from both sides, I get 2y equals minus 6, and then to get rid of the 2 we're going to divide by 2. I get y equals minus 3, and that's it. We've solved the equation. I've got y is minus 3, x equals 4. Right, you can also get a simultaneous equation in words. So I've written this nice and big so that it's clear enough to see. You've got Jack buys 3 adult tickets and 2 child tickets for £23. Amy's going to buy 4 adult tickets and 3 child tickets for £31.50. Find the cost of each ticket. So if I zoom out just a little bit so I can keep it on the screen. Remember, the first marks at GCSE are just for writing these into equations. So I've got 3 adult tickets plus 2 child tickets equals £23. That's my first sentence. 3 adults, 2 childs, £23. Okay, if I look at the second line, I've got 4 adults, so 4A, 3 child tickets, so 3C, equals, and £31.50 this time. That then means I've got an equation just like we've done on example 1 and 2. All I need to do is make either A or C the same. So what I'm going to do is I'm going to times top row by 3 and bottom row by 2. So I get 9A plus 6C equals 69. And then the bottom row, I've got 8A add 6C equals 63. that way. This time the C's are both the same and they're both positive, so I'm just going to subtract. 9A take away 8A leaves me with 1A. 6C take away 6C means that it disappears. 69 subtract 63 leaves us with 6. So I now know the cost of an adult ticket. I'm going to use this first equation that we had to work out the rest of it. So if one adult ticket costs me £6, 3 adult tickets is going to cost me £18. So I've got £18 plus 2 child tickets equals £23, and we're just going to solve. So if I subtract the £18, I get 2 child tickets must cost £5, and then if I divide by 2, you get a child ticket is 2.5, or in our case £2.50, since we are talking about money. So there you go, adult ticket is £6, child ticket is £2.50. So you've now got a worksheet to be getting on with a set of questions. Any problems, let me know.